आम्हाला वाटलं तू त्याला मारून अरे मला उठायला उसका भी काउंटर है
Please start off. 3 questions. You will try. Tomorrow we'll discuss. It's all based on what we have discussed so far. Yeah. Good morning. Please write. I'm giving you 3 questions. You please try, and tomorrow we will discuss the 3 questions. Question is number 1. It is based on what we discussed so far. Last lecture we discussed collision, right? Elastic, inelastic, coefficient of restitution. Everyone? First question. A mass M moves with velocity v. Mass M moves with velocity v and collides elastically with another mass, with another identical mass at rest. After collision, first mass moves with velocity v by root 3. First mass moves with velocity v by root 3 in a direction perpendicular to initial. Direction of motion. In a direction perpendicular to initial direction of motion. Then find speed of the second mass. After the collision. Options are V root 3V, V by root 3, or 2V by root 3. Second question. Please write down. I will draw this diagram. Right. A block is kept on the inclined surface. This is nice question. A block is kept on the inclined surface if the inclined plane is given an acceleration. You can see the diagram. If the inclined plane is given an acceleration on the inclined plane, and if the inclined plane is given an acceleration A to keep the block stationary, Then find the value of A. Then find the value of A. Options are G upon tan of alpha, G into tan alpha, G or G upon sin alpha.
When you're saying you want to keep the block steady, basically you want to move the plane and keep the block at rest.
One more and last. Draw this diagram. So basically a quick revision हो जाएगा when you will solve these questions. Please draw this diagram. Question is, these angles are different, huh? Question is, the system is in equilibrium with constant force mg. System is in equilibrium with constant force mg acting on block B. Constant force mg acting on block B horizontally. Hello. Do not think ये mg block का weight, how can it act horizontally? It always acts vertically down. No? This is the external force which I am applying, so that the system remains in equilibrium. Right? Find T1 and T2. You can see T1 and T2 are the tensions in the two different segments, two different strings. Clear? There's three questions. Please close your book. Now pay attention. Any homework for last? For today's? No. Oh, I'm sorry. It's a numerical. Try this. It's a numerical. Okay? Look here. See in NLM, that is Newton's laws of motion, we are done with the first part. We did all the three laws, first, second, third law, right? Momentum, inertia, impulse, these are all the three terms we introduced. Conservation of momentum, collision, types of collision. I tried to solve simple questions on each and every type so that you understand the formulae. Now today, starting with the second part of this LON, that is about work, power and energy, WPE. Here, that is the second part, but this is the separate chapter given in NCERT book. But I consider it as a part 2 only of laws of motion ka second part I'm starting. So here, the first today's discussion is very simple and interesting. It is about, without this we cannot go for the power and analogy. So it is about what? Concept of work. And the most important is work energy theorem. We already discussed work in scalars and vectors. Let's look here. If you remember, I explained you this example while revising vectors. Can you recall this? Yes. Nowhere I am considering friction, okay? All the surfaces are assumed to be smooth surfaces. So frictional force abhi nahi consider kar raha hu. Can you recall, if this is pulled by applying some force, this toy car is pulled by applying some force in this direction. Let's say the force is 200 Newton, but this toy car is getting displaced horizontally. ये direction में displacement हो रहा है. This is of course, both are the vector quantities, such that angle between them is what? Let's say theta, which is equal to 60 degrees, and displacement का magnitude is how much? Let us say 3 meter. Picture clear? I am applying 200 Newton का force at 60 degrees, but the toy car is getting displaced in what direction? Horizontal direction. In this case, work done, number one, first point. If I want to calculate, you get it at the dot product का concept, no? Work done is not simply force into displacement. It is not just Fs. It is what? Fs cos theta. Are you understanding? It is what? Fs cos theta. Fs cos theta becomes more meaningful if I write like this. F cos theta into S. So when I want to calculate work done, I am not interested in total kitna force is being applied. I am interested in how much force is applied in the direction of displacement. Or else, I am also interested in finding the component of displacement in the direction of force applied. Whether you write F cos theta into S, or you write F into S cos theta. I hope you guys understand. Dot product ka meaning is what? To find out the component of any one vector along the arc. So either you are finding the component of force along displacement, or we find component of displacement along the force. Are you understanding? In this case, F cos theta, force ka displacement ki direction mein component, it will be 200 cos 60, na? What is 200 cos 60? 100. Cos 60 is off, no? Cos 60 is off. Yes. So 200 Newton ka force if you apply at 60 degree, how much is the effective, the component? Every vector has different effects in different direction. Yeah, of course, this force ka ye direction mein kuch alag effect ho sakta hai, over here, every direction mein has different effects. Only at right angle direction mein you cannot find out the effect. Cos 90 zero hota hai. मतलब ये force का in this direction perpendicular to that कोई भी effect नहीं होगा. Otherwise you can find out effect in any direction by finding the components. So I said 200 Newton at 60 degree, 200 cos 60, Fs cos theta, 100 Newton is responsible for the work done. I mean for the displacement, sorry. And I said displacement is how much? 3. So total in this example, the work done will be what? Is this clear? Yes. Number one, work is not force into displacement, it is force into Fs cos theta. It is not just Fs, it is Fs cos theta. You get it with the dot product. Second point, the most important point, जो आज तक कभी नहीं स्टडी किया, what? You can use this formula Fs cos theta only provided this force is what? Constant throughout the displacement. I said this toy car is getting displaced from here to here, let's say by 3 meter, throughout the displacement, 200 Newton का at 60 degree if you find out the component, that is what 100 Newton. So constantly 100 Newton का force is acting in this direction, I can say. That is responsible for 3 meter का displacement. Then only you can use this relation. This formula Fs cos theta is applicable only when the force is constant. So now tell me what should be my next discussion. What if the force is variable force? Here comes integration का concept and work energy theorem का छोटा सा discussion and some beautiful questions on it.
So that 300 joule is the work done by the force or the object?
Of course the force, the one who is pulling it. Object is not doing work.
Object को अगर बोलेंगे तो पूरा net force consider करना.
Yeah, correct. Work is done. Who is pulling this? Suppose a boy is pulling this particular toy car, so he is doing the work. Is that clear? If suppose I remove this particular surface, so this trolley will go down. So gravity is doing the work. So there are many concepts: work done by gravity, work done by the object, work done on the object. So किधर positive, negative conventions लेना है, right? And that's very important in thermodynamics. Work done by the system, work done on the system, right? And unfortunately, in thermodynamics, conventions are exactly reversed in physics and chemistry. जहाँ पे हम लोग पॉजिटिव मानते हैं, they take chemistry में नेगेटिव. तो थोड़ा सा, alright, fine. We have to be little bit careful. Alright, is this simple point clear? This relation is to be used only when the force is
constant.
Think if from this point to this point constantly force vary हो रहा है. Don't you agree? This becomes very difficult to calculate work done in that case. I am not sure कि यहाँ से यहाँ 1 मीटर का डिस्प्लेसमेंट हुआ कितना फोर्स था. 1 मीटर में भी 0.5 मीटर 0.5 में डिवाइड किया तो कितना, I mean the force is what? Exactly at what position, how much is the force, or at what instant, how much is the force? Accordingly, I need to calculate the work done. I can't go with this formula. There we require, if the work is done by the variable force, there we require some graphical concept. Please try to understand this one. Listen properly.
Sir?
Yes.
Here can we consider the average force?
That's what I'm doing. But graphically. Yes. Same thing. Suppose in general बात करते हैं y and x. I have not considered any physical quantities on y and x axis. Just a simple graph, mathematical concept. If I draw this graph of y versus x, and let's say this graph is something like this. Let's say this something like this. Constantly y is variable. ये graph का meaning समझ में आ रहा है? Is it a straight line graph?
No.
It's a curve. No part of the graph is remaining parallel to x-axis. Agar graph is remaining parallel to x-axis, then I can say that y quantity is remaining constant. Na?
Yes.
If the graph is parallel to x-axis, I can say y का value fixed रहेगा. Then in that case it is remaining constant. Your is y remaining constant throughout the displacement. I don't know. Let's say it is from. Let's say it is from here x1 up to x2. मैंने x का lower and upper limit लिया. When the x is varying from x1 to x2, you can see y is constantly varying. No part of the graph is remaining constant. Think now, instead of y, can I say now it is force? And instead of x, let it be x only. Let's take that x as displacement. तो मैं कौन सा ग्राफ ड्रॉ किया मैंने? Force versus displacement. Guys, here it was very simple analysis where the force was remaining constant. Whether, let's say this is the origin. I can say here the x is equal to 0. I can say, and let's say this is the position where x is equal to 3 meter. Displacement लिखा है मैंने. So from 0 to 3, constantly force remains constant. So don't you agree? इसका graph is so simple to understand and analyze. ये x की वैल्यू ले रहा हूँ 0 to 3, constantly 300 न्यूटन का फोर्स is acting on it. Yes sir. But that's the same thing now I'm showing there constantly from x1 to x2. Question comes, why from x1 to x2? Why not from origin? You can start from origin यार, कोई फर्क नहीं पड़ता. I just wanted to take in general discussion, इसलिए मैंने x1 to x2 लिखा. So already let's say the trolley is at certain position from the origin. From there it is starting its displacement because force started working on it. Okay? So here from x1 to x2, no part of the graph is remaining constant. In that case, how do I calculate the work done? इतना समझ में आ रहा है, work is equal to Fs cos theta.
Yes.
And if suppose these two are in the same direction, then theta will be equal to what? 0. Cos 0 will be equal to what? 1. I am not sure from year to year constantly force vary हो रहा है. Then what force I should substitute here and how to calculate that total कितना displacement हुआ है and what is the force acting on it? Though from x1 to x2 constantly force vary हो रहा है, can I consider a very small part of it, extremely small, so-called infinitesimal small displacement? I hope you guys understand. भले छोटा curve है, but उसका एकदम छोटा part लिया, you can always take it as what? Straight. As if imagining that कि over that much interval, the force का value will not change. So tell me, here in this case, suppose if I consider a very small, infinitesimal small displacement. I hope you guys understand. मैं integration के concept से जा रहा हूँ. Can you recollect same thing we discussed in impulse? Because there also the force is constantly variable. Right? There also we consider the average, the total effect. Are you crying? मैं क्या बोल रहा हूँ समझ में आ रहा है? Last bench students, can you see this? Let's consider this displacement as very small displacement. उसको क्या लिखते हैं? dx. Mathematics में, or maybe delta x you can write, but that is tending to almost to 0. So we call it as what? dx. For इतना, Shrujan, yes or no? For इतना displacement, very small displacement, can I imagine that the force is going to remain constant?
Yes.
हाँ ना?
Yes.
Hardik Khedekar, you had asked me doubt here when I explained the impulse. I remembered. I will revise that point again. Can I calculate if it strip मैंने लिया? Strip समझ में आ रहा है? Shaded part. उसका area how do I calculate? Stick to basics में एक rectangular strip दिख रहा है. Let's say हाँ correct. Let's say for this the corresponding force is what? F. but वो constant है. So can I say this is going to be F into what? dx. Rectangle है ना? उसका y coordinate is nothing but the force ना. Y coordinate में मैंने force mark किया, right? Quantity. And my x coordinate is the small displacement, infinitesimal small displacement dx. So what is the area of this particular strip? It is F into dx. Yes or no?
Yes.
Area of the strip समझ में आ रहा है? Rectangle का area. What is rectangle का area? L into b.
Yes.
So width here is dx and height here is L. I mean sorry F. So the F into dx is the area of the strip. Can I imagine right from x1 से लेके x2 तक the displacement when it is taking place? I can split this complete area because see I cannot find out area of this particular curve ना, area under this curve ना, because there's no fixed geometry here. What formula you apply to calculate the area? Are you getting my point? So idea is what? एक strip का area निकालो, that you integrate from x1 to x2. मतलब integration का meaning what? You imagine x यहाँ पे भी एक strip है, यहाँ पे दूसरा strip है, यहाँ पे third strip है. So infinite number of strips are there right from x1 to x2. Question was, sir but ये strip देखो और ये strip देखो, उसका area तो same नहीं आएगा ना, because force का value will differ. हाँ ना? I might give dx same, dx same, but everywhere that force will vary ना. So that's what I'm telling you. I'm not saying force constant है, but वो strip के लिए भी I can use the same funda ना. उसका जितना भी force रहेगा, let's say F1 into dx, then F2 into dx, then F3 into dx. That's the idea. So you imagine as if from x1 to x2 there are infinite number of such small strips. Keep on adding the area of each strip, you get what? The total area. So when the number of components are very large, we don't go with this notation ना, we go with this concept ना. बात तो एक ही है. Summation मतलब to add up the things. मैं वही कर रहा हूँ. But because the components which I number of elements which I want to add, number of strips का area which I want to add, I am taking it very large number. So we go with what? We go with what? Integration का concept. Have some water बेटा. Are you understanding? मैं क्या बोल रहा हूँ? So area of strip के concept से मैं कहाँ पे जा रहा हूँ? Area under
fx का
ऐसे चलेगा लिखा तो? Area under fx को लिखा तो चलेगा? What is that equals? अभी ना एक सिंपल सा पॉइंट समझना प्लीज. It is integration of f dx. Can you understand with respect to what I am integrating your dx मतलब with respect to displacement?
yes
So here when you put the limits, you understand इसको indefinite integration बोलते हैं. There is no limits. When you put the limits means within some specific limit lower to upper I am integrating. हाँ ना?
yes
Do you understand here also there is a definite integration? I am going from x1 to x2. Yes, with respect to what variable you are integrating? So don't you agree उसकी limits आनी चाहिए? Not 3 Newton to 5 Newton. Wrong हो जाएगा. Mathematics समझ में आ रहा है? So I should tell me what should be the upper limit? x1. मैं x1 से लेके x2 तक integrate करना. Area of this fx curve. But मेरा assumption है, let's take the same example where the force is not constant, let's say it is f, it is variable. तो मेरा assumption है कि जो total displacement हो रहा है, let's say from x1 to x2, तो over this displacement, over this displacement, over this displacement, over this, ये सब dx मान रहा हूँ. तो over every dx the corresponding force variable है. तो I'm just calculating the area. तो my assumption is that for every small displacement, ये force का एक component, तो theta तो मैं 0 ही ले रहा हूँ. हाँ ना? So don't you agree f into x area of fx curve is nothing but what? Work done. So work done का formula you get when the force is variable as w is equals to what? Integral f dx. Where that x का variable limit are from x1 to x2. ये definite integration का part हुआ है? No, I will do it. मतलब पहले अपर लिमिट है लोअर लिमिट पर तो उसका सिंपल एप्लीकेशन अभी आ रहा है. विल बी सॉल्विंग क्वेश्चंस ऑन इट. क्वेश्चन कम्स दैट बट फोर्स वेरिएबल है तो कैसे सब्स्टिट्यूट करना है? व्हाट डू यू मीन बाय वेरिएबल? इट विल बी गिवन विद रिस्पेक्ट टू x. बट अब सोचो मैंने फोर्स का ऐसा इक्वेशन दे दिया 2x + 3 सिंपल ये वेरिएबल हुआ ना. बट व्हेन x is 0 force is 3 Newton. When x is 1 it's going to be 5. When x is 2 it's going to be 7 like that. वो फोर्स तो वेरिएबल हुआ. तो आपको करना क्या है? सिंपल मैथमेटिक्स. फोर्स का इक्वेशन विल बी गिवन. पुट इट हियर. टिपिकल नीट क्वेश्चन है. फोर्स का इक्वेशन विल बी गिवन. इजी इक्वेशन. यू जस्ट पुट इट हियर. इंटीग्रेट इट. लोअर अपर लिमिट सब्स्टिट्यूट करके इसका आंसर. कैन माय आंसर बी नेगेटिव?
yes
Go mathematically. If theta is 180 degree, can the cos 180? I mean, can it be negative? Cos 180 is what? It depends what he asked me. Depends किसकी वजह से you are calculating your work. Suppose if I am pulling the toy car here like this in this direction, so work done by me will be positive because theta acute angle है. But if you imagine, I have of course not introduced that concept, but if I introduce the concept of friction here, तो don't you agree friction ये direction में act होगा?
negative
हाँ ना? तो उसकी वजह से work done will be what? Negative. तो means the energy is lost actually against that. Friction के against system is doing some work, उसका energy is getting lost. There is some loss of energy. So depends. Work can be negative. I hope you understand. Go mathematically as if now. कोई numerical में I will come to this point. Mathematically क्यों बोल रहा हूँ? Because if theta is 180, cos 180 can be? Can work be 0?
yes
Work is 0 का भी theta है? Theta 90 का मतलब what? Tell me. अरे वो ठीक है. थीटा 90 मतलब परपेंडिकुलर का मतलब व्हाट? अरे यार थीटा 90 cos 90 0 का मतलब व्हाट? घुमा रहे हो. ना इक्विलिब्रियम नहीं. मतलब when the two vectors are perpendicular you cannot find इसका component along this. हाँ ना? Tell me as long as this trolley is moving horizontally I said, is there any work done by the gravity?
zero
वो बोल रहा हूँ. Gravity मतलब gravitational force. Where is it acting constantly? Where is the gravitational force acting? तो उसके ऊपर खाली ये force नहीं है जो मैं लगा रहा हूँ. There is a gravitational force also acting on it, no? But that constantly gravitational force is acting where? And where is the toy car getting displaced? तो यहाँ पे gravity is not doing any work. जय am I clear? वेदांत am I clear? मैं क्या बोल रहा हूँ समझ में आ रहा है? हाँ ना. एक सेम सिमिलर लगता है प्लेस, एक लिजान करके वो है मुंबई में. Are you understanding? Gravity is not doing any work now. So work can be zero, it can be positive, it can be negative. थीटा के ऊपर सब डिपेंड करेगा. Acute angle 90 डिग्री, obtuse angle, yes or no? हाँ ना?
Yes.
By default कुछ नहीं बोला है. He considered theta to be equal to what? Zero. Theta zero मतलब displacement की direction में I am applying the force and correct. Next point. Can you guys recall? एक मिनट. Can you guys recall? मैंने ऐसे भी कुछ बोला था कि why sir you are thinking about only cos component? ये analysis में to calculate work done, Rathi. Sit straight. In this example to calculate work done मैंने कौन सा component लिया? Cos component. But sin component लिया नहीं, but उसका analysis तो आ सकता ना? Tell me यार ये क्या होगा? 100 sin 60 ना? बोलो यार. तो 100 sin 60 is what? अरे 200 sin 60 is what? 100 root 3. तो 100 root 3 क्या कर रहा है? Upward direction में कुछ motion हो रहा है क्या? It must be getting balanced ना? अरे न्यूटन फर्स्ट पे यार. तो ट्रॉली का weight must be acting downward. तो वो बैलेंस कर रहा है. तो this is not linear contact. मैंने एक साथ जर्क दे दिया तो ऊपर भी उड़ के फिर वो पेंडुलम जैसा ऑसिलेट करेगा टॉय कार यार. हाँ ना? So I am not showing it, but yeah, of course वो है, वो कंपोनेंट तो आएगा ही. एक कंपोनेंट नहीं, जनरली भी मिनिमम कितने कंपोनेंट में भी रिजॉल्व? 2 म्यूचुअली परपेंडिकुलर. गिरिजा हाँ यस सर.
हाँ वो उसमें अभी जो बोला उसमें डाउट है, मतलब वो
100 sin 60.
हाँ 100 sin
200 sin 60.
हाँ तो 100 root 3 प्लस वो नॉर्मल रिएक्शन बैलेंस करेगा नेट.
हाँ नॉर्मल रिएक्शन तो आएगा.
हाँ और वो f का जो इक्वेशन है 2x plus 3
हाँ
जो मतलब क्वेश्चन में आता है f का x में इक्वेशन
I'm taking my question on it.
वो कैसे डिराइव है?
नहीं वो दिया रहेगा कुछ भी. मैं अभी दे रहा हूँ रैंडमली. मैं तो क्वाड्रेटिक इक्वेशन दे रहा हूँ और उसको इंटीग्रेट करके सॉल्व, खाली इंटीग्रेशन का प्रैक्टिस के लिए. तो यू आर नॉट सपोज टू डिराइव इट बेटा, दैट विल बी गिवन. यस सर.
सर इक्विलिब्रियम में क्यों नहीं?
व्हाट? इट इज एन इक्विलिब्रियम बट वर्टिकल डायरेक्शन.
नहीं जीरो डिस्प्लेसमेंट है ना इक्विलिब्रियम में.
इक्विलिब्रियम में जीरो. वर्टिकली इक्विलिब्रियम में है. बोल रहा हूँ, दैट्स व्हाट इज माय पॉइंट.
नहीं आपने बोला ना इक्विलिब्रियम नहीं होगा.
अरे ओवर हियर ना हॉरिजॉन्टल इक्विलिब्रियम नहीं है, ऐसा बोल रहा हूँ. वर्टिकल में है.
हो सकता है ना, बस फोर्स कम है,
फ्रिक्शन है तो ना. फ्रिक्शन नहीं ले रहा हूँ ऑफ कोर्स. इफ देयर इज अ फ्रिक्शन, हेलो इज इट नेसेसरी मैंने इसको कुछ बेंच के ऊपर इतने न्यूटन फोर्स अप्लाई किया तो ये सब कुछ इट इज वेरी हैवी, तो नॉर्मल रिएक्शन ज्यादा, फ्रिक्शनल फोर्स ज्यादा, इसमें ऑफ कोर्स. बट मुझे तो कंसीडर करना है इक्विलिब्रियम नहीं है तो वर्क डन जीरो ही होगा ना, कितना भी फुल करो. इज अ सिंपल पॉइंट क्लियर? एक वेरी इंपॉर्टेंट डिस्कशन, प्लीज लुक हियर नाउ. लगा शॉट? मेरा एंगल थोड़ा कम कर दे. योर कंपोनेंट इन दिस डायरेक्शन विल इंक्रीज. ऑलराइट, लुक हियर. वर्क डन विल बी मोर व्हेन द एंगल इज लेस और इट विल बी मोर व्हेन द एंगल इज मोर.
लेस में हाँ
कैसे कैलकुलेट किया?
close to 1
And theta increases, cos theta decreases. So theta should decrease, so cos theta will increase. Cos उल्टा चलता है. That's why I said as theta become 90 degree. एक मिनट बहुत ब्यूटीफुल पॉइंट है. देखो ना, ये फोर्स है, ये डिस्प्लेसमेंट का वेक्टर था. What did I do? I resolved it ना ऐसा. Actually ये कंपोनेंट है ना f cos theta. What do? We just drop a perpendicular from the tip of the vector. Don't you agree? ये थीटा है. This is theta. Don't you agree? यहाँ पे जितना थीटा, राशि दिख रहा डायग्राम, जितना थीटा इंक्रीज होगा, देखो ना, जितना थीटा इंक्रीज होगा, बट चलो सोचो ना, दिस कंपोनेंट इज डिक्रीजिंग. You keep on dropping perpendicular, you will understand. Suppose ये वेक्टर इधर आ गया, तो अभी कंपोनेंट बताओ ये होगा. f cos थीटा डिक्रीज हो रहा है, थीटा इज इंक्रीजिंग. और ज्यादा हुआ, और ज्यादा एंगल लो, 90 हो गया तो सीधा 0 हो जाएगा. That's what is my point. तो परपेंडिकुलर कोई भी वेक्टर का राइट एंगल डायरेक्शन में कंपोनेंट फाइंड नहीं कर सकते. Is that very clear? Let's go ahead. Priya, are you understanding? Coming tomorrow? Look here. क्या पानी भर के लाओ, बैठ इधर. ले उसको. अभी तो आया, स्टार्ट हुआ, पानी भर के आओ, वॉशरूम जाके आओ. Please look here. Now coming to what? यहाँ पे क्या लिखना चाहिए मुझे हेडिंग? वर्क डन
Force maybe which
due to which force? Hey, hello everyone, are you with me? Work done due to variable force. Now look here. Now look here. What is the equation we got? Work is equals to integration of x1 to x2 f dx. Let's do not consider the limits. The limits are as per the question. So w is equal to integral f dx समझ में आ रहा है? What is integration? Addition. एक strip, दूसरा strip, keep on adding the area of each strip. Most of the time, now coming to very important point, work energy theorem. Suppose if I say work is applied on an object which is initially at position A, let's talk about this trolley only, which is initially at A, and then it is reaching to point B. बराबर समझना. Initially it is at A, कुछ तो origin से position है. I am applying force, it got displaced, getting displaced to good position B. But in the question I am not giving you the coordinates of A and B. Like how I gave you your x1 to x2 जा रहा है ऐसा. I am not giving the variable, coordinates of these positions A and B. Instead of giving you variables, coordinates I mean to say, the positions of A and B, what am I giving you is this information. कि मान लो when it is over here, उसका initial velocity is u and उसका final velocity is v. It's not necessary that every time object will be at rest only initially. It can be in the motion, it might have some velocity. और मैंने force apply किया, accelerate किया, the velocity got increased. हाँ ना, velocity कम भी हो सकता है यार, depends कि force if I am applying in the opposite direction, तो velocity कम भी हो सकता है, retardation. हाँ ना, are you understanding क्या situation है? I am applying force on an object